Hello, assalamu alaikum everyone. So in today's class, we are going to look at sinusoidal inputs half-wave rectification. Okay. So in today's class, we are going to look at half-wave rectification. Okay. So let's consider a sinusoidal input. Okay. Let's consider a sinusoidal input. Okay. So this is our sinusoidal input. Okay. And this is VI. Okay. And we will give this input to a rectifier circuit. Okay. And the output will be something like this. This is V out. Okay, now this voltage it's called AC voltage. Okay, AC, and this voltage it's called DC voltage. Okay, DC voltage. So why is it called alternating voltage or AC voltage? Because in this voltage sometimes the voltage is negative and sometimes the voltage is positive. So in this part okay, the voltage is positive, and in this part the voltage is negative. Okay, whereas in the output side, okay, it is called DC voltage because the output is always positive. Okay, so DC voltage it's always positive. Okay, and what about AC voltage? AC voltage it's called AC, okay, because it's sometimes it's positive, okay, and sometimes it's negative. Okay, so what is the purpose of a rectifier circuit? Okay, so the job of a rectifier circuit is to take AC input and give DC output. Okay, so I can write more generally, okay, that a rectifier circuit, okay, a rectifier circuit, it will take AC input and it will give DC output. Okay, so this is the job of a rectifier. So in today's class, as I have already told you, that we are going to look at half wave rectification. Okay, half wave rectification. Okay, so now let's consider this circuit. Okay, in figure 2.43. Okay, let's consider this circuit. In this circuit, we have a diode and we have a resistor, and we have a sinusoidal input. Okay, so we have a sinusoidal input. Okay, this is T, this is 0, this is capital T by 2, and this is capital T. Okay, this is VI. Okay, so this is VM. Okay, and this part is minus VM. Okay, now let's analyze this circuit. Okay, so for the input, okay, the input is positive when time is between 0 and capital T by 2. Okay, so between 0 and T by 2, okay, for okay, what is VI? VI or VI is positive. Okay, so if VI is positive, okay, let's look at this circuit. Okay, so if VI is positive, the polarity of VI will be like this. Okay, so the current will try to flow in this direction, in clockwise direction. Okay, so when the current is flowing in the clockwise direction, the diode will be forward biased. Okay, because current is flowing in the positive direction through the diode. Okay, So when diode is forward biased, okay, so Vi is positive. When Vi is positive, diode is forward biased. Forward biased, okay. And we are assuming ideal diode, okay, that is short circuit, okay. Forward bias means short circuit, okay. So if the diode is short circuit, no voltage will drop across the diode, okay, because its resistance is 0, okay. So all the resistance, all the voltage will drop across the R, okay, across R. So V out will be Vi. So when Vi is positive, diode is forward biased or short circuit, V0 will be equal to Vi. The output voltage will be Vi, okay. So we have a output voltage which is very similar to the input voltage, okay, in the positive half cycle, or positive half cycle, positive in the positive half cycle. Now for T, now in the negative half cycle, okay, the input voltage is negative, okay. In the negative half cycle, the input voltage is negative. So for T by 2, okay, so T greater than T by 2 but less than capital T, okay. So in this region, Vi is negative, okay. So what happens to the diode? So let's look what happens when Vi is negative, okay. So when Vi is negative, the polarity of Vi changes, okay. So this is now the polarity of Vi, isn't it? So the now current will flow in this direction, in anti-clockwise direction, okay. So when current is trying to flow in the anti-clockwise direction, okay, the diode becomes reverse biased, okay. The diode becomes reverse biased. So what happens? The diode becomes open circuit. So diode is reverse biased. Diode is reverse biased, okay. That is open circuit, okay. So we already know that when sorry, in an open circuit, okay, in an open circuit the resistance is infinity. So if the resistance is infinity, all the voltage will drop across that infinite resistance, okay, because the resistance is so large that it will, I mean, consume all the voltage, okay. So what will be the output voltage or the voltage across the resistor R? It will be 0, right? So V out will be 0, okay. V out will be 0. So this is for negative half cycle. So this is for negative half cycle. Now we can draw the total output, okay. So let's draw the input again first. So this is our input curve, okay. So this is Vi, okay, and this is capital T, and this is Vm, maximum voltage Vm, okay, and this is minus Vm. Okay? So and this is T is equal to 0, T is equal to T by 2, and T is equal to capital T. Okay? So for this input, what will be our output? Okay. So this is V out. Okay. What will be the output? T by 2, capital T. So the output will be equal to the input. Okay. Let me. The output will be equal to the input. Okay. V0 is equal to Vi. Okay. In the positive half cycle, and in the negative half cycle, V out will be 0. Okay. Because in the negative half cycle, we have seen that the diode is reverse biased. So all the voltage will be dropped across the diode. Okay, so this is our, and this is Vm. Now, what is the average value of this output? Okay, the average value of a half wave rectifier, okay, the DC value, you can say VDC, is nothing but 0.318 Vm. Okay, 0.318 Vm. This is for half VDC for a half wave rectifier. For sorry, this is the VDC for now you might ask that what is VDC? Okay, VDC is nothing but average value. What is VDC? VDC is nothing but average value. So what is the average value of this input voltage? Okay, the average value of this input voltage is 0. Why is it 0? Because in this part, okay, in this part we have positive values of voltage, and in this part we have negative values of voltage. So if we add the positive values and if we add the negative values, okay, and if we take the average of them, okay, the total, the result will be 0, right? Okay, because we are, DC is nothing but average. Okay? But in the output voltage we only have positive values, okay, because the negative values we have rectified. Okay, we have eliminated the negative values. That's why the circuit is called rectifier, because it has removed the negative values of the input from the output. Okay, that's why it's called rectifier. So the DC value of a half wave rectifier is 0.318 Vm. Okay, so you just remember this. Okay, just remember this. You don't need to know the derivation. Okay, or if you want to know the derivation, you can ask me in class. I will discuss further in the class. Okay, how this value comes. Okay, so this is the average value of a half wave rectifier output. Okay, this is the DC value of a DC value of the output of a half wave rectifier circuit. Now, so far we have assumed that the diode is ideal. Okay, we have assumed the ideal model of the diode. Okay, now my question is, what if we consider, let's say, simplified model? Okay, so as we have already studied that in simplified model there is threshold voltage. Okay, whereas in ideal diode, in the ideal model the threshold voltage is 0. So if we consider the simplified model of the diode, okay, simplified model of the diode, then what will be the difference? Okay, what will be the difference? If we consider the simplified model, now we know that in simplified model we need to consider the threshold voltage, okay, and the diode will turn on only after it has crossed the threshold voltage. Okay, so let's say this is Vt. Okay, this is Vt. Okay, so when the input voltage is less than Vt, okay, when the input voltage is negative, the diode is definitely off. Okay, and the diode is also off when the input voltage is less than Vt. Okay, because the diode will not turn on until the threshold voltage is crossed. So only the diode will only turn on when input voltage is greater than Vt. Okay, so we will only have this part of the input in our output. Okay, so our output will be something like this. So this is for the simplified model. Okay, so why is it like this? So if this is Vm, this is Vm, the peak of the simplified model diode will be Vm minus Vt. Okay, because if the diode is ideal, okay, the diode will turn on when Vi is 0. Okay, just when Vi is positive, the diode will turn on. But in the simplified model, the diode also the V input also need to cross threshold voltage. Okay, so the output voltage will be Vm minus Vt. Okay, the maximum output voltage. Okay, Vm minus Vt. I hope this is clear. Okay. So for ideal diode, if the maximum output is Vm, okay, for a simplified diode, okay, the diode will consume Vt voltage. Okay, so the output will be Vm less Vt, Vm minus Vt. Okay, so the output will be Vm minus Vt. Okay, so so if so V out is Vi minus Vt. So this is for simplified model. Okay, and what is the VDC of a simplified model? Minus Vm minus Vt. Okay, this is the simplified model DC value. Okay, so I hope this is clear for everyone. Okay, because the equivalent circuit of a simplified diode, okay, the equivalent circuit of a simplified diode is something like this. Okay, simplified model. Where is this? Okay, this is something like this. That you have an ideal diode. Okay, this is an ideal diode, and you also have threshold voltage. Okay, so okay, so this is Vt. Okay, so this is positive, this is negative. Okay, let me, this is Vt. Okay, this is positive, this is negative. Okay, so this is actually our simplified diode model. Okay, simplified diode model. So we have an ideal diode and we also have a threshold voltage. So this simplified diode, okay, so this is simplified model. Okay, so this simplified model will turn on, okay, when the Vi is or Vi is greater than the threshold voltage. Okay, so just remember, okay, that this simplified model of the diode will turn on when Vi is greater than the threshold voltage. Okay, and the output will be this red curve. Okay, so the black curve, it's for ideal diode, and this red curve, this is for simplified diode. So this is how half wave rectifier works. Okay, so this is our half wave rectifier. So go through this math. Okay, go through these examples. Example 2.18. Then okay, now let's come to PIV. Okay, so this is the last topic for today's class. PIV. What is PIV? Okay, so PIV is the maximum reverse bias voltage. Okay, the maximum reverse bias voltage that appears across a diode is called PIV. Okay, So PIV stands for peak inverse voltage. So peak means maximum, inverse means reverse bias, and voltage means voltage. Okay, peak reverse voltage or peak inverse voltage. Okay, so when will be the when I mean so when is the diode reverse biased? Okay, when is the diode reverse biased? When V input is negative, right? So when V input is negative, and what is the most negative voltage of the input? Vm. Okay, Vm is the maximum negative value. Okay, the input cannot be more negative than minus Vm. Okay, so our PIV rating must be greater than Vm. Okay, PIV rating is PIV rating should be greater than Vm. Okay, because Vm is the maximum reverse bias voltage that will appear across the diode. Okay, so let me explain you using the practical diode model. Okay, so our practical diode looks something like this. Okay, so this is the Zener voltage Vz. Okay, so suppose our Zener voltage is, let's say, minus 20 volt. Okay, minus 20 volt. Okay, minus 20 volt. So now if our input voltage Vm, let's say Vm, it's 10 volt. Okay, then what will be the peak inverse voltage? Okay, what will be the maximum reverse bias voltage that will appear across the diode? That will be minus 10 volt, right? Because for a sinusoidal curve, it's from 10 volt to minus 10 volt. Okay, so the peak inverse voltage will be minus 10 volt. So that means this is the maximum voltage that will appear across the diode. But the green curve, it is the characteristic curve of the diode. Okay, so the Zener voltage of the diode is what? Minus 20, but our maximum negative voltage is minus 10. Okay, so our PIV rating is greater than the VM, right? But let's say, for example, let's say now our VM, let's say it's 25 volt. Okay, let's say our VM is 25 volt. Let's say we take a sinusoidal input. Okay, that is fluctuating from 20 volt to, oh sorry, 25 volt to minus 25 volt. Okay, so VM, let's say it's 25 volt. Now, what will be the maximum reverse bias voltage? It will be minus 25, right? So it will be somewhere here. So this negative voltage, it is beyond the Zener voltage of the diode. So if we take this green diode, okay, can this green diode block the 25 volt? No. Because why? Because the PIV rating of this green diode is less than VM. Okay, the PIV rating of this green diode is less than VM. So our PIV rating is of this green diode is 20 volt, but our VM is 25 volt. So our diode will enter the Zener region, okay, and it will break down. It will become damaged. So what happens? So how can we fix it? We need to take a diode, okay, which has a PIV rating greater than minus 25, okay, greater than minus 25. So I hope you have understood what is the significance of PIV rating. Okay, PIV rating is nothing but the Zener voltage of a diode. Okay, it is nothing but the Zener voltage of a diode. And Zener voltage is the reverse bias voltage, the maximum reverse bias voltage that the diode can tolerate, okay, before going to breakdown region, right? So the PIV rating of the diode, okay, or the Zener voltage of the diode must be greater than the maximum voltage of the input, okay? Only then can the diode handle the negative voltage. So that's it for half wave rectification. So in today's class, we have discussed about half wave rectifier circuit, okay? So in the exam, if you are asked to explain the operation of a half wave rectifier, okay, then you need to draw the circuit and you need to explain by showing the input curves and the output curves and what happens when the input is positive and what happens when the input is negative, okay? And Yeah, and why is it called half wave rectifier circuit? Okay, why the circuit that we have seen before? Okay, this circuit, why is it called half wave rectifier circuit? Okay, why this circuit is called half wave rectifier? Okay, so this is Vi, this is V out. So why is this circuit called half wave rectifier? So as you have seen that when the input is positive, the rectifier allows the positive input to go to the output, but when the input is negative, it blocks the negative half of the input. So that's why it's called half wave. Okay, so that means it allows only half of the sinusoidal input to pass. Okay, and it blocks the remaining half. So that's why it's called half wave rectifier circuit. Okay, so in the next class we'll see full wave rectification. Okay, so how can we design a circuit that will allow the positive voltage of the input, and it will also allow the negative voltage of the input by rectifying the negative part also. Okay, so that will be for next class. Okay, so that's it for today's class. Thank you.